All right, 6.6, Fundamental Theorem of Algebra. We're going to kind of tie a lot of what I've probably been already discussing this, throughout the chapter, planting seeds, but we're officially going to get 3 theorems today that basically help us with trying to find zeros and roots of polynomials. So let's just jump right into this first one. The Fundamental Theorem of Algebra. Basically, all that it says is that the main thing is this corollary. Every polynomial that has a degree greater than or equal to 1 has exactly n zeros, all right, including multiplicities. So that means duplicates. So, for instance, if you have something that starts off and it's like, hey, 2x to the 5th plus 4x to the 3rd minus x plus 8, and that's your function, what you can do is you can look to the leading term, the degree, the highest degree of the whole thing, and I know that this thing is going to have 5 zeros, all right? So whatever that biggest power is, you're going to have that many zeros. Now, I don't really know exactly, are they rational? Are they irrational? Are they complex? Because there's 3 different kind of types of zeros there. You have nice friendly numbers that terminate or repeat, can be represented as fractions. Those are rational. Irrational are things that have square roots in them that go on forever. Or you can be imaginary. All right, you're going to have i's in the mix. So let's kind of jump in and let's kind of look at some examples with this. So number 1, find all the roots of this polynomial equation. So, these 2 steps, you could just kind of look right to the graph and try to find zeros from the graphs. I like to use the rational root theorem first. So I'm going to do, first I didn't answer the question. By the fundamental theorem of algebra above, how many zeros are we looking for? So for this problem, we know that we have 4 zeros. So at the end of the problem, we better have 4, otherwise we're missing somebody. The rational root theorem said we're going to do all of our factors of p over q. And q, remember, is this coefficient in the front, which is just 1. So the denominator is nothing but the 1. But then the p is here at the back end. It's that negative 8. And all the factors of 8 are 1, 2, 4, and 8. So basically we have 8 different possible rational zeros, all the positives and all the negatives. So what I could do is I could either A, use synthetic division to try all those, or B, I could actually graph it to find the real ones. So I'm going to choose the graph. So I'm going to pause this video real quick and fire up Desmos, and I'm going to pull this graph up. All right, so I've typed in the equation there up in the upper left into Desmos, and even when I scroll out, I don't see 4 zeros. Basically, I only see 2. So we're going to have some imaginary stuff going on here, some complex numbers. But it does look like I have zeros. I can establish that it's at 1, and then we also have 1 over here. So we got 1 right there and 1 right there. So we have 1 at 1 and 1 at negative 2. So let me go back to my my set of notes here. All right, let's get rid of these dots. So we've established that, hey, we have 1 at 1 and we have 1 at negative 2. So we've located 2 of the 4 zeros. X equals 1, x equals negative 2. Now what I'm going to do is I'm going to use synthetic division to break it down further. So I'm going to come over here, do my synthetic division. Doesn't really matter which number you use. Maybe we'll just use 1 first. So 1, 1, 2, 4, negative 8. Bring the 1 down. 1 times 1 is 1. Add them together, I get 2. 1 times 2 is 2. Add them together, I get 4. 1 times 4 is 4. Add them together, I get 8. 1 times 8 is 8. And I should get 0 because it's a factor. It's a 0 there. So what I've done is I've whittled this down into a new polynomial. X to the 3rd, this would be plus 2x squared plus 4x plus 8 equals 0. So I've whittled it down. Now I'm going to try the other one. I'm going to try this negative 2 up here. And I'm going to go negative 2 into this one. and see if I can whittle it down to a quadratic. That's kind of always my goal, get it to a quadratic. So bring the 1 down, negative 2 times 1, add them up, negative 2 times 0, add them up, negative 2 times 4, add them up. Awesome. And what that does is it finally gives me a quadratic down here where I have lots of ways, there's no x term, because I have lots of ways to solve quadratics. You know, I can factor them, I can use the quadratic formula, I can complete the square, which I really don't do too often. This one I'm actually just going to take the square root of both sides. So I'm going to solve x squared plus 4 equals 0. There's no way to factor that, but I'm going to move the 4 to the other side, get x squared equals negative 4. And since I've isolated x squared, to undo the squared part, I'm going to take the square root, which is just going to give me x. And if I do it to the left, I have to do it to the right. And now we got a bit of a problem. The square root of a negative number does not exist. Your calculator can't do that. So what we've done in the past is we've rewritten that and said, hey, that's really just the square root of 4 times the square root of negative 1, which we have defined earlier in the course that I equals the square root of negative 1. All right, so that's kind of what we did to deal with negative square roots. So that's really just 2i. And whenever you take the square root, you get 2 of them. So there are my other 2 zeros. We have x equals 2i and x equals negative 2i. And I now have all 4 zeros accounted for. 2 are rational, and then 2 are complex or imaginary. We have imaginary numbers in there. All right. Come down, another example. Let's just kind of test this one out. So I'm going to do my P over Q thing, and I'm like, all right, so if I do P over Q, everything that can go into 20, well, we have 1, 2, 4, 5, 10, and 20. All over 1. You know, if that front number was all different than 1, we'd have a lot of fractions we'd have to do, but I'm not really putting you through all that. So I'm going to graph it now because I see that there are, 12 possibilities up here, all the positives and all the negatives. So let's just kind of pause the video. I'm going to run to Desmos and see what we come up with. All right, well, I got the new problem graphed on there, and it looks like I only see a couple of zeros. Looks like I see one right here at 1, and I see the other at negative 5. So we have 1 and negative 5 that we can kind of start working on here. So let me come back to my screen. So we know x equals 1, x equals negative 5. So this was given to me from the graph. And so let's go ahead and synthetic divide these. So I'm going to do the 1 first. 1, 4, negative 1, 16. Remember to be careful. You don't have to put zeros in for a place value. I think we're good. So bring it down as 1. 1 times 1, add them. 5, 4, 20. And I'm going kind of fast in this because I've already done other videos on synthetic division. So I'm not really going to talk through every single step. And now I'm going to use the negative 5 to go through this new one, since I've broken it down. And hopefully after this, I'll have a nice little quadratic we can do. So slide it, add it, 0, 4. Oh, this one looks like it's actually going to be the same. X squared plus 4 equals 0, which is going to save me a little bit of work because I already know that it's going to come out to be 2i and negative 2i. So those are my zeros. I have x equals 2i, x equals negative 2i, x equals 1, x equals negative 5. All right, now we have 2 theorems. Again, we've kind of already talked about these in the course, but they're official now. Irrational roots. So whenever you have to do the quadratic formula and you get, some sort of a square root as one of your zeros, you always have, it's always that plus or minus. So the big thing is that irrationals, as well as complex numbers, all right, they come in pairs. So that's the big thing that I want you to understand is whether it's irrational or whether it's complex, you're always going to have two of them. And when they're complex, they call these conjugates. So we're going to see some of those here in a second. But just know that they always come in pairs. So let's try to do something here. Let's try to work backwards. We did this with quadratics in the quadratic section. But I want to write a polynomial using the zeros. So my idea is if you give me zeros, that should give me factors, which then I should be able to multiply to get a function that has those zeros. So that's kind of the flow chart. So remember, if I have a 0 of -2, that means I have a factor of x plus 2, because that's when that parenthesis would be 0. Then x minus 2 would be his, and then x minus 4 would be the positive 4, 0. So those are my factors. And now we just need to multiply them together. The order's up to you. I like these two because of the difference of squares. I'm going to have something cancel out. So that's going to shake out to be x squared minus 4 because the plus 2x minus 2x cancels. And now I'll just do it times the back piece. So x squared times x to the third, x squared times a -4, -4x squared. That'd be a -4x and a positive 16. And none of these, none of these combine. So these are all their own terms. So I have a generic polynomial, whatever letter you want to use there. So that polynomial for sure will have these 3 zeros. 3 zeros. All right, so that's the easy one. Now we kind of go into the harder example. So this one where you got to kind of stay with me. This one's going to be a little bit longer. And if you were in first hour yesterday, or today, whenever you're doing these notes, I changed this one right here. And I think you're going to thank me for it. Because I left one like that example in the homework. I think it's like number 10 or something. So you'll get to see it, but it's long. All right. When you have the 1 minus or the 1 plus I, it's kind of long. I thought for an introductory example, I would change it. So you're going to have to scratch out your 1 minus I or 1 plus I, whatever it was, and change it to 3i. I know that those have to come into pairs. So the first one they give me, that's pretty straightforward. If the 0's -3, then I know that x plus 3 is a factor. But if you tell me that the square root of 2 is a 0, well, I know x minus the square root of 2 is going to be a factor. But because of the theorem up above, if you give me square root of 2, I also have to include the negative square root of 2. So then we have to think about x minus a negative, which is really going to be x plus. So remember, those irrationals, those square roots, they come in pairs. And then the same thing for this 3i. If you give me 3i, that means that -3i also has to come to the party. So I'm going to end up with an x minus 3i, and then I'm going to end up with an x plus 3i. All right, so I'm going to do this in an order that makes sense as far as things are going to cancel, because I have some difference of squares. So I'm going to do this piece right here first, because it's just going to be x times x. And then the minus radical 2x and the plus radical 2x cancel. And I'm just going to get a minus 2. So that's going to simplify all that nastiness. I'll just keep this here going on the way that it is. And then over here, this is also a difference of squares, this black part. And I'm going to have x squared in the front. And then the minus 3ix plus 3ix goes away. And I end up with the minus 9i squared, but I'm not going to write it just yet, because minus 9i squared, I can do something with that. Remember that if I is the square root of -1, if I square both sides, I squared equals -1. So I'm going to substitute in this -1 for this I squared. So instead of I squared, I'm just writing -1, which ends up being a positive 9. So this makes this really nice to where my eyes disappear. So now I have 3 pieces I have to add together. I don't know. Maybe I'll do these 2 together first. So x squared times x squared, that's x to the 4th. Then I'm going to have a plus 9x squared and a minus 2x squared. So that's plus 7x squared. And then the negative 2 times the positive 9 is a negative 18. And now I need to multiply that by this front piece. So if you want to use a box, you could use a box. I'm going to just kind of double distribute. So I'm going to have x to the 5th plus 7x to the 3rd minus 18x. And then I'm going to have a 3x to the 4th, which kind of goes right in here. And then a 21x squared. And then a negative 54. So wow, when I put all this together, I'm going to have f of x or p of x, whatever you want to call it. I'm going to have x to the 5th plus 3x to the 4th plus 7x to the 3rd plus 21x squared minus 18x minus 54. So I believe that is the function with all 5 of those zeros. And what I'm going to do is I'm going to zip over to Desmos, and let's just verify. You know, we're looking for x equals negative 3, and then the square root of 2, and negative square root of 2, which those are roughly, 1.4 and negative 1.4. So those are the 3 zeros we're looking at. We can't really see the I ones, but we should be able to see those 3. So let's go over and check it out. Have that in here. And it looks like when I go to my graph, kind of zoom in here, it looks like I definitely have the 1.414, the negative 1.414, and the negative 3. So I think it's pretty safe to say we did this one right. All right, hopefully these help you out. There are a couple problems on the practice that you might need a little bit more hints and a little bit more help with, but we'll knock those out in class.